Hello everyone, this is Varshini L, a student of Sri Venkateshwara College of Engineering, pursuing BE in Computer Science and Engineering. This presentation explores the concepts of equivalence relation and partitions. Introduction to equivalence relation. Equivalence relations are the special type of binary relation on a set. They must satisfy the three properties: reflexivity, symmetry, and transitivity. Understanding these properties is crucial for identifying the equivalence classes. Yeah, let us discuss the properties one by one. First is reflexivity. A relation or in a set A is reflexive if every element is related to itself. For all A in A, the pair A, comma A must be relation to or. This property ensures that every element has a self relationship. Symmetry is a relation or in a symmetric if for any two elements A and B. If A is related to B, then B is related to A. This means that if A comma B is in R, then B comma A must also be in R. Symmetric helps establish two-way connection between the elements. The another property is transitive. A relation or is transitive if whenever A is related to B and B is related to C, then must A be related to C. Formally, if A comma B and B comma C are in R, then A comma C should also be in R. This property allows us to chain a relationship among the elements. Next is here some examples of equivalence relation. An example of equivalence relation is a congruence modulo n on integers. Another example is having the same birthday among the people. This example illustrates how equivalence relations group elements based on their shared properties. Equivalence classes. An equivalence class is a subset of a set formed by the elements that are equivalent to each other. Each element of the set belongs to exactly one equivalence class. The notion of the equivalence classes helps in organizing elements based on their relationships. Definitions of partitions. A partition is a set is the way of dividing it into non-empty and disjoint subsets. Each element of the set must belong to exactly one of these subsets. Partition arise naturally from equivalence relation through equivalence classes. Here the relationship between the equivalence relation and the partitions. Equivalence relation on a set induces a unique partition of that set. The equivalence classes formed by the relations are the subsets of the partition. Conversely, every partition defines an equivalence relation through membership in the same subset. Example of partition. The set of integers can be partitioned into even and odd integers. A partition of a team can be made based on the position, such as forwards and defenders. This partition highlights how elements can be grouped based on their specific criteria. Finally, the conclusion of these equivalence relation and the partitions are foundational concepts in the set theory. Understanding their properties and relationship is essential in mathematics. These concepts have application in various fields, including computer science and topology. And thank you.